Alright, so in this video we're going to talk about how to do a hypothesis test for a mean. Because in the previous video we talked about that population standard deviation being unknown, and that's what we're going to be working with here. So we're going to be seeing that t-distribution showing up again. So first I'm kind of looking through our 5 steps that we're generally going through to do a hypothesis test. And we've seen a few other hypothesis tests at this point. Let's talk through the little things that are different inside this hypothesis test. Alright, so first what you see is a nice little pattern, just like when we did a single proportion, is that we had the proportion equaled a number. This time it's going to be that the mean, this population mean, equals a number. So this mean 0, when we actually do a problem, will always be some type of number. Now with the alternative hypothesis, we can choose any of our 3 options of that not equal to, the less than, or the greater than. And again, how we choose our sign depends upon the problem. Alright, so if we're trying to see if the mean is different than some value, or if we're trying to see if the mean has decreased, or if we're trying to see if the mean has increased, that's going to help me determine which sign I want to choose here for my alternative hypothesis. My decision rule is still to reject the null hypothesis, and for me that generally means that we're going to then believe the alternative hypothesis if our p-value or our probability that we calculate is less than our alpha. Step 3 requires some conditions if we're asked to do them. So our conditions that we need basically mean our central limit and the whole. So we need to make sure we're taking a random sample, that we're not doing things in biased ways that we learned back in Unit 2. My second condition, remember this is an or between them. We either need to know that things are normal, which this can either be stated in the problem for us, or sometimes we might be given a histogram to look at to see if it looks relatively symmetric and unimodal. Right, that's how we can check to see if it's normal or not. Or we need a sample size of at least 30. This third condition is something I've added in here really to kind of help us with why things are different inside this set of notes. Our population standard deviation will be unknown, but just as a little reminder to ourselves, especially when we're doing a problem, the sample standard deviation, S, will actually be known. So we will still have a standard deviation. It will just now be the sample standard deviation instead of the population standard deviation. So the reason why this third condition is here is to understand that when I go over here to my test statistic calculation, that that's why I'm going to have this t. Alright, so it's really this condition that's leading to me using this t over here instead of the z that we had seen up until this point. How our t is calculated looks a lot like what we saw in the last video. The only difference is here on this mu, I put this little 0 on here. So that's just to remind me that whatever number from here is coming from what number I have up there as well. And then we divide that by s over the square root of n. Now if you remember from the t-distribution video, I said the spread of the t changed based upon our sample size. So how that actually changes with the t is this new thing called df, which just stands for degrees of freedom. So that's one of the other things that we have to know for a t-distribution. And in this specific case, it's our sample size minus 1. So that's how the sample size is going to play a role. So that number will also affect what our probability or our p-value that we get will actually be. In step 4, we're going to calculate our p-value, or again, our probability. And at this point, we're going to let StatCrunch do the work for us. We've already understood how to calculate a p-value using z distribution. So we'll talk about why it looks a little bit different and those types of things through our first example. Once we have our p-value or our probability, we can go back up to step 2, compare it to our significance level, our alpha, and see if we're going to reject or fail to reject our null hypothesis. Then once we know that, we can do our interpretations. The other little note you'll see here before we look at our problem is how to do this information in StatCrunch. So there's two different ways that we can do it. We can have the actual data set, and so that talks you through that, versus the summary information, and we'll explain the difference as we go to StatCrunch with our first example. So those are our 5 steps, and the goal next is we will apply these ideas to a problem. So in this problem, we're going to be doing some of the old stuff that we learned as well. This is sort of some nice review. So in 2015, our mean house price in the United States was about $214,200. Now, if I look up to that point, I haven't seen anything but a sample being taken. So if anything, I'm probably thinking that that's going to be my mu, because I don't see a sample. I would like to see if this value is higher in 2018. This is giving me this idea for my alternative hypothesis. I'm going to be using a greater than sign there. In order to test this, we took a random sample of 150 houses. So that's going to be my sample size. And found the mean house price was $216,400. So that's going to be my Y bar, with a standard deviation of 31,700. Now what you'll notice of this number is asking yourselves, what is it attached to? It's attached to these 150 houses, or it's attached to my sample. So this $31,700 is my sample standard deviation. So it's going to be an S and not a sigma. And it probably tells me that house prices are generally skewed right. So, first question asks us to use the appropriate rule, either Chebyshev or the normal curve rule, to describe individual house prices back in 2015. So, the first thing I would notice is that it did tell me that my distribution is skewed right. So, I can't use that normal curve rule, that 68, 95, 99.7 rule. I'm going to have to use Chebyshev's rule. So I like to just do this on a number line for myself here. So we're going to start at our mean in 2015, which was $214,200. And then now I need to go out up to 3 standard deviations in both directions. I don't actually know my population standard deviation, so I'm going to use the one that I do have, which was my sample standard deviation. So again, I'm going to the left, I'm going to subtract the $31,700 and see what we get. And then on the right, I'll be adding the $31,700. And so as I'm going to the left here, I got $182,500. Subtract off another $31,700, and I get $150,800. And subtracting it off one more time, I get $119,100. Now the other direction, we're just going to be adding the $31,700. So for my first one, I get $245,900. Doing it again, we get $277,600. Doing it a third time, we get $309,300. So there's my sort of math done. And so what I know about Chebyshev's rule is if I go out one standard deviation, that doesn't give me any useful information. If I go out 2 standard deviations, I get about 75%. And if I go out 3 standard deviations, I get about 90%. And so I can just interpret those here. So then I can say that at least 75% of houses in the United States prices between are $150,000, $800, and our $277,600 in 2015. And then I could say then that at least 90% of houses in the U.S. had prices between, and this time it's $119,100 and $309,300 in 2015. There's an idea of what house prices look like in 2015. And so now, looking at how our problem was stated, what is going to be my hypothesis? So again, generally it's easier to write the alternative hypothesis first, because that's one that we read up here. We want to see this value is higher in 2018. Higher, so give that greater than sign, higher than what? What it was in 2015. So this $214,200 number. Now once I have my alternative set, my null hypothesis has no choice. Same symbol, same number, always that equal sign between. We're also going to talk about some errors, just to remind ourselves of those. So we talk about what a type 1 error means in the context of our problem. So first, just remembering what a type 1 error actually is. So this is if we reject the null, what makes it an error, the null is actually true. So what would that mean here for us? That's going to mean that I believe the mean house price has increased. That's what I'm going to believe. If I reject the null, I'm going to mean that mean house price has increased. What makes it an error? It hasn't actually increased. So if I were to commit a type 1 error, we're talking about some consequences that could happen. So one thing that I might do, if I'm someone who is wanting to sell my house, then I might list my house at too high of a price. Which one of two things could possibly happen here then? Right, maybe then I don't sell it. Or then I end up having to lower my price and sell for less than I wanted it for. If I list my price too much, people might not buy it at all, or I end up having to settle for a price that maybe I wasn't happy with. So that'd be one example of a consequence. You could come up with some others as well. Like that, maybe if you were someone buying, you might not think you can afford a house now. Or you think prices are higher than they were before. You might not think you can afford a house. But another example of a consequence. Now, as we turn the page here, just remember all these numbers that are showing up over here that we're going to be using. So we have our hypotheses already. I have my sample size. I have my sample mean. And I have my sample standard deviation. So I'm going to need those numbers as we continue. So now we're actually going to go through and do the hypothesis test using a 1% significance level. So that's telling me that my alpha is going to be 0.01. So my first step is just my hypotheses, which we'd already done in part B. So I'm just going to relist those numbers here for us. So nothing new there. Alright, for my second step, that's that decision rule. So I'm going to reject the null hypothesis and instead believe my alternative hypothesis if my p-value, or again probability, is less than my alpha, which my alpha was given to me there is at 1% up here, so my 0.01. Alright, step 3. Again, don't mean to do conditions when you're asked, but we're going to do them here for demonstration. So for our conditions, let's talk about if we have a random sample or not. So all it said is to take a random sample of 150 houses across the United States. So we don't really know how they really sampled these houses, but I don't know anything bad about how they sampled them. So if they maybe would have told me instead that they sampled all houses from California, that would be a problem, but they didn't tell me that. So from at least what I know, there's no known bias in how they collected their sample. For my second condition, I either need to know it's normal or have a sample of at least 30. Going back and reading the problem, it didn't say anything about it being normal. More specifically, it actually said that it was skewed to the right. So then it isn't normal because it's not going to be symmetric. So I know that that first part of that one is not met. So I'd rather have this sample size of 30, which I do, because my sample size was 150. And then finally, this third condition is just really to remind us why we're using the t-distribution. So our population standard deviation is unknown, because I actually just had a sample standard deviation of the 31,700. Our other part of step 3 is our test statistics, so using our formula. And first, let's remind you what our formula looks like. And so we do actually already have all of these numbers to plug in. So our sample mean was $216,400. Our mu0 is our number that shows up in our null hypothesis up here, so the $214,200. Our sample standard deviation was the $31,700, and we sampled 150 houses. So then doing the math there, I'll continue it up here. We get $2,200 over. Our standard error here is at 2,588.29, which gives us a t of 0.85. So then for step 4, we're going to calculate our p-value. Now I mentioned we're going to use StatCrunch, but it's sort of nice to understand what we're doing still. Remember, our t is going to look a lot like our z, it's a little bit more sat on. It's still centered at 0. I'm still going to kind of put my little marks on here for me to work with. So my t was 0.85. So that's going to be about right here. And then going back to step 1, I usually ask myself, am I doing a one-tailed or a two-tailed test? We're only looking in one direction, so it's going to be a one-tailed test. More specifically, it's when we're looking for that greater than, which means we're going to shade to the right. So at this point is when we will go to our table to calculate our p-value. Remember, now I have a t, not a z. So I'm going to actually be using this, going to StatCrunch to get my results there. For this one, we're going to be using the summary information option. So the summary information means that everybody's going to have the numbers that summarize it. So I have my sample size, I have my sample mean, I have my sample standard deviation. So we're going to go to StatCrunch using those directions that we learned here using the summary information. So I open my StatCrunch, and we're going to go to our stat, T statistics, one sample, and then if you have the data, which would mean you actually had all 150 house prices, or we can just go to our summary information. So my sample mean, my Y bar, was $216,400. My standard deviation was $31,700, and my sample size was 150. Then here, I'm going to make my hypotheses look like the ones we wrote in step 1. So the number I had here in my null hypothesis was $214,200. And then for my alternative, we had a greater than sign. Once I have that, I'm just going to hit my compute button, which gives me my results here. Which if you'll notice in the notes, I gave us actually 2 sets of output. So the difference here is, notice here is the greater than sign. Here would have been the 2-tailed test. Notice the only thing that changes in your output then is actually your p-value. So making sure you have the right sign to give you the right p-value. That can make a big difference if you have the wrong sign there. So then now my p-value, or again, we can just call our probability. I'm just going to get from my output. So this is the one I'm going to choose because my sign matches. So my probability here is 0.1983. Now that I have this, all my calculations are done. We're going to go back here to step 2 to check if that number we just got is less than 0.01. It is not. So we're not going to reject. Instead, we will fail to reject the null hypothesis. Which basically means that we are not then going to believe our alternative hypothesis. So then for step 5, is just our interpretation. So starting with our alpha level of 0.01, since we did not reject, there is not statistically significant evidence. To support that our mean house price in the U.S. has increased in 2018. And for myself, I like to have compared to 2015. Those are 5 steps for our hypothesis test for a mean, now using the t distribution. To end this video, I just wanted to talk about how z and t are different, and the smaller your sample size is, actually the bigger discrepancy there's going to be. So first, just to show you what would have looked different here, you can technically do the same thing with the z. The difference is it assumes that this is the population standard deviation instead. It's going to put in the exact same numbers that we had before. So that's what our output would look different. So if you notice, things are pretty much labeled the same, except for here it's called a t-stat instead of a z-stat, which does actually affect your p-value. So to show how big of a difference that can actually make, we're going to change numbers to be a little bit different in each one. So first on this one, I'm just going to make my sample mean a little bit bigger. And make my sample size a little bit smaller. So there's one for that one. I'll change this one to be the same numbers. That's going to be 18, that's going to be 75 instead. You kind of see how this changes. Again, the z-stat and the t-stat are the exact same number, but notice that the p-value is different. Let's do it again. Make that one even bigger. This one be even smaller. And it's even bigger here. I try to change these exactly the same here. Again, slightly different looking p-value. And all I'm going to do, I'm going to make the sample size extremely small. So this is going to be 5. So there's that for them. Again, you notice that the p-values can be different, so making sure you go to the right menu is pretty important. Okay, so do make sure that you realize when you have the sample standard deviation versus the population standard deviation, and then you'll actually never go to this menu, so this is one that we will be going to here. I hope that's a nice example for a hypothesis test for you. In the next video, we'll look at a confidence interval.